Okay, let's look at two more examples of approximating the area underneath the curve using the idea of rectangles. So we're going to look at the function square root of x plus 2, and we're only going to look at this graph from 0 to 2. So what we're trying to do is come up with an estimate for this area underneath the curve, but we're going to go ahead and use rectangles, and delta x is going to be the width of the rectangles that I want you to use. So first type of rectangle, we're going to use a lower sum. All that means is I want you to come up with an underestimate. So the width of the first rectangle is going to be 1, which I'm telling you, and you have to figure out where should I hit this curve to make it an under approximation, because I want a lower sum. If I hit it on the left and go straight across, notice the rectangle is under. If I go across here, the rectangle is over. So I want to use this as my first type. So the height of the first rectangle is be f of 0, which in this case is actually 2. The next one, width is still 1. Again, if I want to be under, I need to go across this way. There's my next rectangle. The height of that rectangle is f of 1. So f of 0 is 2. F of 1, this is exactly 3. So the area of these two rectangles added together is 5. So the exact area has got to be something bigger than that, because obviously we're missing these pieces. Let's do the same thing, but this time I'm going to use an upper sum. So in order to get an upper sum, I need to be above the curve. So my width is still 1, that doesn't change, but this time I'm going to draw the rectangle like this. So I'm going to hit the curve at x equals 1, or the right side. So this would be f of 1. Plus the second rectangle, still width is 1. I'm going to make it hit on the right side. If I go straight across, notice the height of the second rectangle is f of 2. And you can just use your calculator at this point to punch out these numbers. This is the original function. So f of 2 would be square root of 2 plus 2, whatever that number is. If you do this, I get 6.4142 something. And it makes sense. This number is bigger than this number because we're doing an overestimate. Okay? We're going to do one last rectangle with this one. We're going to do what's called a midpoint. And exactly like it sounds, we're going to use a rectangle that's exactly in the middle of the curve. So the width of the rectangle is still going to be the same here. I'm still going to use 1, but this time my height, instead of using 0 or 1, I'm going to hit in the middle, which is 1/2. So I'm going to make it hit right here in the curve, and if I draw it straight across, notice now your rectangle, some of it's above, some of it's under. The height of the rectangle will be at f of 1/2. I'm going to do the same thing with the other one. Notice the width is still the same. It's still 1, but this time I'm going to hit it at exactly 1.5 in the middle. Sorry, 1.5 is right there. So then you get a rectangle that's half above, a little bit above, a little bit below. It's not exactly half. And again, plug these back into the original function to punch out the y values. But if you do this, this ends up being 5.9318. So notice your lower sum is under, your upper sum is above, your midpoint is somewhere in between. So the actual should be closest to the midpoint approximation. Right now we don't know how to come up with the exact area. Okay, let's do one last one. Function is going to be 1 minus x squared, and I'm going to look from -1 to 1, and we're going to use delta x equals 0.5. So sketch the curve always first so you can get an idea of what's happening. So 1 minus x squared looks like this, but I only want to look at the graph from -1 to 1. -1 is here, +1 is here, so this is the area I'm trying to come up with. Okay, notice here I'm asking you to use a width of 0.5, so I'm going to need these pieces here as well. Okay, so let's think about, let's say I want to do inscribed first. So my width of the rectangle is 0.5. That will always be given. And if I want to do inscribed, think about, do I need to hit it on the left and go straight across, or hit it on the right side? For the inscribed, I will need to hit it on the left. So the height of the first rectangle is f of -1. Plus, same thing here, the next width is 0.5. Notice I'm going to hit on the left side again, so this is -1/2. So the next height would be at f of -1/2. Plus, you're going to have a total of 4 rectangles. Now, when you start going on the right side of the graph, this is 1/2 here, this is 0. In order to be inscribed, notice if you hit it on the left side at 0, you're going to go over. So this time, you're going to actually hit it at 1/2. And the reason is because this curve starts increasing then decreasing, so that's why you have to change which side to hit it. So your inscribed might not always necessarily be the left side or the right side. So the width is still 0.5 and the height of that is f of 1/2. The next one would be 0.5 f of 1. And if you punch this out, your inscribed area should be 0.75. Okay? Now, for this, if you're going to do the circumscribed, same thing, width is still the same, never changes. So I'm still going to use 0.5 for the width. You're still going to have 4 rectangles, but this time I want to go over the curve. So notice the first rectangle, I have to hit the curve at -1/2. So there's my first height. The next rectangle, I'm going to hit it at 0. So it's going to be f of 0. Next rectangle, width is still 0.5. This time I'm going to hit it at 0. Last rectangle, I'm going to hit it at 0.5. So these are my 4 rectangles, and if you punch this out, your circumscribed area, or your upper sum in this case, would be 1.75.